Today we discuss about the preparation of preparation of phenols. Today I would like to discuss about the preparation of phenols. Preparation of phenols. Phenols can be prepared by hydrolysis of diazonium salts. Phenols can be prepared by hydrolysis of diazonium salt. Diazonium salt. So, what is the diazonium salt? Diazonium salt is what is a diazonium salt? Diazonium salt is nothing but aromatic primary amines. Aromatic primary amines undergo digestion with nitrous acid in acid medium uh, to produce diazonium salt. If the reaction temperature is more than 10 degrees centigrade, these diazonium salt undergo hydrolysis to produce phenol. To produce phenol. To produce phenol. Phenol. So aromatic primary amines undergo digestion with nitrous acid in acid media to produce diazonium salt. If the reaction temperature is more than 10 degrees centigrade, these diazonium salts undergo hydrolysis to produce the phenols. To produce the phenols. So here it is an amine, aromatic amine, which is treated with nitrous acid in presence of an acid medium. We can take the sodium nitrate in presence of an acid medium to form the diazonium salt. This diazonium salt on warming water or dilute acid produce alcohol and N2 gas and HCl is forming. So this is the reaction which is occurring in the preparation from the diazonium salt. So the first step is the preparation of the diazonium salt. This diazonium salt on heating about 10 degrees centigrade, they produces the phenol. They produces the phenol by undergoing the hydrolysis. By undergoing the hydrolysis, this diazonium salt is stable only at below 5 degrees centigrade. Below 5 degrees centigrade. So when you come to the next one, when you come to the mechanism, what is the mechanism is going on here is nothing but sodium nitrate is treated with HCl. Sodium nitrate is treated with HCl. We forms the sodium chloride and nitrous acid. Sodium chloride and nitrous acid. So the structure of the nitrous acid is like this. The structure of nitrous acid is like this. In this, when you are treating in the acid medium, the H plus is reacted with the OH minus OH. The lone pair of electrons which is present on the oxygen is donated to the H plus ion and forms the hydronium ion. So the plus charge of the oxygen is unstable and leaves the water molecule and converts the NO2 plus. NO2 plus is forming. NO2 plus is forming. This NO2 plus is reacted with amine. That means the lone pair of electrons which is present on the nitrogen is donated to the nitrogen. And forms the bond with the between the nitrogen and nitrogen. Here the lone pair of electrons is donating, so it is getting the positive charge. If electrons is taken, so minus and plus is neutralizing here. So neutralizing here. So if these electrons are migrating here, the pi electrons is migrated towards the oxygen. So oxygen is getting the minus charge. Here it is removing as H plus. This H plus is reacted with the O minus and forms the OH. So when these electrons are migrating here, this is removed as OH minus. This OH minus and H plus react together and forms the water molecule and forms the N triple bond N plus. So here the Cl minus is there. So it is forming like this. This is called as a diazonium salt. Diazonium salt. So this is stable only at 5 degrees centigrade. 5 degrees centigrade. If you use above 5 degrees centigrade, it is reacted with water and converted to the phenol, and it is N2 is liberated as N2 gas. Liberated as N2 gas, and HCl is reacted with H plus and forms the hydrochloric acid. So this is the one of the preparation for the phenol. One of the preparation for the phenol. Another, if the phenol can be prepared in the large quantities in the industries, we are using the we are prepared from the cume. Cume is nothing but isopropyl benzene. Cumin is nothing but isopropyl benzene. It is prepared from the Pradal-Craft alkylation of benzene with propane in presence of AlCl3 or H3PO4. Cumin isopropyl benzene is prepared by Pradal-Craft alkylation of benzene with propane. Pradal-Craft alkylation of benzene with propane in presence of AlCl3 or H3PO4 or H3PO4 or H3PO4. So when you come to this reaction, this is the reaction. So what you are saying that benzene is reacted with the propane, alkylation will take place. Alkyl group is adding to the benzene. So this is the general. This is the formation of isopropyl benzene. Isopropyl benzene. When you see the mechanism for this reaction, here what happens means in a HCl. Okay, isopropyl is treated with HCl. It forms isopropyl chloride. This isopropyl chloride is reacted with AlCl3 and forms the complex like this. And removing as AlCl4 and forms the carbocation. This carbocation is reacted with the benzene and forms the isopropyl benzene. Isopropyl benzene form. This isopropyl benzene on oxidation with air. That means cume on oxidation with air to form cumin hydrogen peroxide, hydroperoxide. Cumin hydroperoxide is formed, which in hydrolysis with the dilute sulfuric acid gives the phenol and estone, that is propanol. When you see this reaction, this is the reaction. This is isopropyl benzene, which is reacted with oxygen to form cumin hydroperoxide. Cumin hydroperoxide, which on hydrolysis to form the phenol and the estone. What is the mechanism here going on is nothing but the lone pair of electrons which is present on the oxygen is donated to the carbon. So carbon valence is increased. It is converted into 5 membered carbon. So it is a highly unstable. So it removes as H plus, H minus, and this is here it is forming the H plus. The H minus is reacted with the oxygen and forms the cumin hydroperoxide. So here these electrons are migrating here, these electrons are migrate here. Then H plus is reacted with O and forms the cumin hydrogen peroxide. Cumin hydrogen peroxide is treated with an acid, which an hydrolysis in the presence of acid. That acid means H plus ion, which is reacted with H plus ion forms the hydrogen ion. Hydrogen ion is unstable, so it is removing as H2O, water molecule, and it is undergoing the rearrangement reaction. It is undergoing the rearrangement reaction. Rearrangement reaction forms the carbocation, and forms the carbocation. So this carbocation is reacted with water molecule and forms like this. So H2O plus is unstable, so it is removing as H and forming like this, estone. So these on further hydrolysis, it is converted to phenol and estone. Phenol and estone is forming. So this is about the preparation of phenol in large quantity. Preparation of phenol in large quantity. If you want to prepare the phenol in large quantity, you are using this method. The next one now, when you come to the physical properties, what are the physical properties of alcohol? Lower alcohols are colorless. Toxic liquids. They have the characteristic smell. Higher members are always solids. Higher members are always solids. Boiling point is increases while increasing regularly with the number of carbon atoms. While increasing the number of carbon atoms. While increasing the number of carbon atoms. Some of the examples here we are mentioning. Among isomeric alcohols, as a branch increases, the boiling point decreases. Boiling point decreases. So next one, phenol. When you come to the phenol, most of the phenols are colorless liquids or solids. Most of the phenols are colorless liquids or solids. Although when they are exposed to the air, they turns to the red color. They turns to the red color. Phenols have the characteristic carbolic order. They're having the some of the carbolic order is forming. Carbolic order. Next one, in this one of the important properties hydrogen bonding. What is a hydrogen bonding? Hydrogen bonding means the partial bond formed between hydrogen and highly electronegative atom is known as hydrogen bonding. Hydrogen bonding is nothing but the partial bond formed between the hydrogen and highly electronegative atom. Highly electronegative atom. Highly electronegative atom. These are two types: intramolecular hydrogen bonding and intermolecular hydrogen bonding. Intra means the hydrogen bond is formed between two groups. Two groups. Two groups in the same molecule. In the same molecule is called as intramolecular hydrogen bond. If the hydrogen bond is formed between the two groups in the same molecule is called as intramolecular hydrogen bond. So let us take an example, orthonitrophenol. Here the hydrogen bond formed between the oxygen and the hydrogen, which both are present in the same molecule. So it is called as intramolecular hydrogen. Here orthonitrobenzoic acid, here the partial bond which is formed between the oxygen and hydrogen within the same molecule. So it is called as intramolecular hydrogen bond. And the hydrogen bond formed between the two groups within the same molecule is called as intramolecular hydrogen bond. Intramolecular hydrogen bond. If the bond formed between the two molecules is called as intermolecular hydrogen bond. The hydrogen bond is formed between the two molecules is called as intermolecular hydrogen bonding. If you take water molecules, two water molecules, the partial bond which is formed between the oxygen and hydrogen is nothing but intermolecular. Acids, two acid molecules, or we can take two phenol molecules. Like this, we can take the so many types of examples. Examples for the intermolecular hydrogen bond. Intermolecular hydrogen bond. So when you come to the another important question is the character of phenol. Is the character of phenol than alcohol? Is the character of phenol and phenol? Acidic character of phenol is more than the alcohol. Why? So it is one of the important questions. According to Bronsted theory, proton donor is an acid. According to Bronsted theory, the proton donors are known as acids. And which donates the proton, which donates the H plus ion is called as an acid according to the Bronsted theory. Bronsted theory. Acid characters uh, according to Bronsted theory, proton donor is an acid. So the acidic character. Let us see the example here. So due to the phenol is a phenol group is a electron withdrawing group. Phenol is a electron withdrawing group. That means the phenol, the ring, is attracts the electrons from the oxygen. So attracts from the oxygen means oxygen is having the partial positive charge. So it is easily removes the hydrogen and forms the phenoxide ion. Phenoxide ion. So the due to the powerful electron withdrawing nature of the phenol group, it decreases the OH bond strength in the phenol. And the bond between the OH is decreases because the electrons are pulling inwards to the ring. So that decreases, so it is easily removes the H plus ion and easily donates the proton. On losing the proton, the phenol gives the phenoxide ion. If you remove the H plus, then it forms the phenoxide ion. This phenoxide ion is stabilized by resonance. Is stabilized by resonance forms. So if the H plus is removed, then it is converted to phenoxide ion. This phenoxide ion undergoes the resonance like this. So when these electrons are migrating here, these 5 electrons are migrated to this carbon, and the carbon getting the negative charge. So this minus charge is migrated to inward direction. This is migrated to this carbon and get the carbon minus charge. So this is again migrated to inward direction. This carbon is migrating here. So we are getting the 3 resonating structures. We are getting the 4 resonating structures, 3 resonating structures for the phenoxide ion. Phenoxide ion. So this type of resonance is not possible in the ethyl alcohol. When you see the ethyl alcohol, if the H plus ion is removed, then it is converted to ethoxide ion. Ethoxide ion is only forming. There is no resonance structures. So if the resonance structures are increasing, the stability is increases. That means it is easily, and minus charge is stabilized. So H plus ions is removed very easily. So that's why phenol is more acidic than the alcohol. Phenol is more acidic than the alcohol. Phenol is more acidic than the alcohol. When you come to the chemical properties, uh, formation of alkoxide or phenoxide ion. Alkoxide or phenoxide ion. Alcohols or phenols react with active metals like sodium, potassium, magnesium, aluminum to form a metal alkoxide or metal phenoxide and liberating the hydrogen gas. And hydrogen gas is evolved. Here we are saying that alcohol or phenol are having the acidic nature. We are saying that alcohols and phenols are having the acidic nature. When you are treating an acid with any metal, it liberates the hydrogen gas. Like that only here also the takes place. That is, the phenol is reacted with the sodium metal. It forms the sodium ethoxide and releasing the hydrogen gas. If you are reacting with the phenol is reacted with sodium metal to form sodium phenoxide and liberating the hydrogen gas and liberating the hydrogen gas and liberating the hydrogen gas. Next one, when you come to the another application, this is one of the application for the application, one of the chemical property, and we see the another chemical property, that is reaction with alkyl halides. And the alcohols react with alkyl halides to form ethers. Alkoxide or phenoxide ion react with alcohols or phenols react with alkyl halide to form ether. This reaction is known as Williamson synthesis. Simply say that it is takes place in the presence of alkali medium. Alkyl halides reacts with alcohols or phenols in the presence of either to form in the presence of basic medium to form the ether. to form the ether. The thing is here, sodium chloride is sodium halide is removing and forms the ether. Forms the ether. So next, another important application is esterification. What is an esterification? Esterification is nothing but alcohols reacts with carboxylic acid or its derivatives in presence of concentrated sulfuric acid to form ester. To form ester. This reaction is known as, the formation of ester is known as esterification. Esterification is nothing but alcohols reacts with the carboxylic acid or its derivatives in presence of an acid to form an ester. It is known as esterification. And that means carboxylic acid derivatives are nothing but ester. Acid derivatives are nothing but ester, acid chloride, acetic anhydride. Like this, we are all of the examples for the acid derivatives. So first of all, we see with the carboxylic acid. Carboxylic acid react with alcohol in presence of an acid to form an ester. To form an ester. So this is an acid. This is an alcohol. Is treated in presence of HCl to form an ester. So first of all, in the first step, the acid is reacted with acid. That means the lone pair of electrons which is present on the oxygen is donated to H plus, and forms the oxygen positive charge generator. It generates the positive charge. Oxygen, the positive charge which is present on the oxygen is highly unstable. So the pi electrons is migrated towards the oxygen, and the lone pair of electrons which is present on the oxygen in the alcohol is facilitated to react with the carbon. And forms like this. Here again, oxygen is carrying the positive charge. It is unstable. So to neutralize this, it is reacted with O. It is takes from the hydrogen, right? Hydrogen H plus. This H plus is reacted with OH and forms hydronium ion. So again, hydronium is an unstable, so it is removed as a water molecule and forming like this. So here it is again oxygen is carrying the positive charge, so it is removed as the H plus ion and converted into the ester. This is about the from the carboxylic acid. If we take from the acid chloride is the derivative of carboxylic acid. Acid halide is the derivative of carboxylic acid. Alcohols reacts with acid halides to produce ester. Is an excellent to produce an ester. Here we can say that this is acid chloride. It is reacted with alcohol to form the ester. What happens here means the lone pair of electrons which is present on the oxygen is donated to the carbon. Then the pi electrons is migrated towards the oxygen. So oxygen is getting the minus charge. Here oxygen is getting the plus charge. So it is again migrating here. It is removing as a Cl minus. So Cl minus abstracts the proton and forms the HCl and converts to the ester. So this is the mechanism from formation of ester from the acid chloride. Next one, acetic anhydride. When you see the acetic anhydride, the lone pair of electrons which is present on the oxygen is donated to one of the carbonyl group, either of the carbonyls. They forms like the same mechanism which is obtained in the acid chloride. So in the acid chloride we are getting the HCl. In this we are getting acetic acid. Acetic acid is obtained. So some of the special reactions with phenol, some named reactions we see. So here the minus charge is present on the ortho position and para positions. So it is reacted with when you are adding an electrophile. Electrophile reagent, it is readily reacted at the ortho and para position. Ortho and para positions. Ortho and para positions. Let us take one of the named reaction, that is a Kolbe-Smith reaction. Kolbe-Smith reaction. Kolbe-Smith reaction is nothing but sodium peroxide. Sodium peroxide is heated at 120 to 140 degrees centigrade under pressure with carbon dioxide. Sodium peroxide is heated at 120 to 140 degrees centigrade under pressure with carbon dioxide. With carbon dioxide to form sodium salicylate. Sodium salicylate. This sodium salicylate on hydrolysis to form orthohydroxy benzoic acid. This is known as salicylic acid. This reaction is simply known as Kolbe-Smith reaction. Kolbe-Smith reaction. And what you are saying is sodium peroxide is reacted with the carbon dioxide at heated with the carbon dioxide at 120 to 140 degrees centigrade. 140 degrees centigrade, that forms the sodium salicylate. Sodium salicylate is formed. This sodium salicylate on hydrolysis to form orthohydroxy benzoic acid. This reaction is nothing but Kolbe-Smith reaction. We are taking the sodium phenoxide is treated with CO2, this CO2, and forms the sodium salicylate. This sodium salicylate on hydrolysis to convert the salicylic acid. What we are here happening here means, so when you are converted, this is a C minus and Na plus. So phenoxide ion is stabilized by resonance. So here the negative charges is present on the ortho and para positions, and CO2 is act as a electrophile. CO2 is act as a electrophile. So this attracts the electrons from the ortho position and forms the substituted product like this. So it is removing the H plus ion and it is converted to sodium salicylate is formed. Sodium salicylate on hydrolysis we get the salicylic acid. Another one of the important named reaction is Riemann-Tiemann reaction. In Riemann-Tiemann reaction, phenol is treated with chloroform. Phenol is treated with chloroform and aqueous. Phenol is treated with chloroform in the presence of alkali. That is sodium hydroxide or potassium hydroxide, to form orthohydroxy benzaldehyde or parahydroxy benzaldehyde is formed. This reaction is known as Riemann-Tiemann reaction. Phenols are converted into phenols is treated with chloroform in presence of aqueous alkali. That is NaOH or KOH, which is dissolved in the water, to form ortho and para products of orthohydroxy benzaldehyde or parahydroxy benzaldehyde is obtained. This reaction is known as Riemann-Tiemann reaction. In Riemann-Tiemann reaction, we are getting orthohydroxy benzaldehyde and parahydroxy benzaldehyde by treating the phenol with chloroform in the presence of alkaline sodium hydroxide. What happens here means NaOH is dissociated Na plus and OH minus ion. This OH minus abstract the proton present in the chloroform and forms the carbanion. This carbanion loses the chlorine ion and converts to carbene. Carbene is forming. This carbene is attacks at ortho or para positions. Ortho positions or para position. Because it is an electron rich position, so it is reacted at ortho or para product is obtained. So this is an hydrolysis, we get the dichloromethane, and further hydrolysis is converted into salicylaldehyde. The next one, coupling, coupling or isocoupling. It is already discussed in the preparation preparation of phenol, preparation of phenol. So after the diazonium chloride, we are already discussed in the previous one. This diazonium chloride is again treated with phenol. Diazonium chloride is treated with phenol at 0 to 5 degrees centigrade. We get the azodine. Azodine. Azodine is forming. Azodine is forming. So coupling or isocoupling is nothing but first we have to prepare the diazotization. After diazotization, phenol couples with diazonium salt in presence of mild alkali solution to form para-hydroxy isobenzene. This reaction is known as a coupling reaction or diazocoupling. And the phenol and the diazonium salt coupled together and forms the para-hydroxy isobenzene. This reaction is known as coupling reaction or diazocoupling. This is called as diazo group. So when you see the mechanism, here the mechanism is like this. We already discussed in the previous one up to the formation of diazonium salt. This diazonium salt is reacted with the phenol. Phenol and forms the azodine product. Azo product is obtained. So this is the mechanism for the azocoupling reaction. And next one, Pierce rearrangement. Pierce rearrangement. This is not an important topic, so we skip this. And another most important one is Phenol-Phenol rearrangement. Phenol-Phenol rearrangement. That is 1,2-dihydroxy compounds are known as phenol. 1,2-dihydroxy compounds are known as phenol. Phenol means alcohol. So phenol means alcohol groups. Phenol, that means it is converted into keto group, and alcohols are converted into keto group. In this reaction, the alcohols are converted into keto group, and in phenol rearrangement, the alcohols are converted into keto groups. Phenol is treated with mineral acids like sulfuric acid or phosphoric acid. They undergo dehydration and rearrangement to form the ketone. To form the ketone. The ketone is known as the ketone formed from the phenol is known as phenolone. This rearrangement is known as phenol rearrangement. The phenol is treated with mineral acid. They undergo dehydration and rearrangement to form ketone. The ketone formed from the phenol is known as phenolone rearrangement. This rearrangement is called as phenolone rearrangement. So this is the phenol. It is treated with sulfuric acid. It is converted into phenol. When you see the mechanism, it takes place in the 4 steps. In the first step, the H plus which is present from the acid is reacted with one of the OH group in the phenol and forms the hydronium ion. So hydronium ion is unstable, so it is shifting will be takes place and forms the carbocation. So here it is a tertiary carbon. Tertiary carbocation is a more stable, but when compared to the tertiary carbocation, the carbocation which is attached to the heteroatoms is more stable. Heteroatoms is more stable. So that's why it undergoes 1,2-alkyl shift, and the alkyl group is a shift from here to here, and forms the carbocation on this. Carbocation is obtained here. So here the alkyl group is shifting from here to here. Then the carbocation is generated on this carbon. Why? Because here already tertiary is more stable, but it is shifting takes place to acquire the more stability, to acquiring the more stable carbonium ion. And 1,2-alkyl shift is to yields the more stable carbonium ion. Tertiary more stable అయినప్పటికీ ఇది ఎందుకు షిఫ్ట్ అవుతుంది అంటే ఇక్కడ ఇంకా స్టెబిలిటీ ఎక్కువ ఉంటుంది. Here it is more stable than tertiary. Why? Because the carbon is attached with the heteroatom. So it is uh, the lone pair of electrons which is present on the oxygen is donating and converted to like this. So H plus it is removing as a H plus and forms the ketone. Finally, H plus is removing and forms the keto. Keto group is forming. Keto group is forming. So this is the mechanism which is involved in the phenol-phenolone rearrangement. Phenol-phenolone rearrangement. So how can we distinguish primary, secondary, and tertiary alcohols? It is also one of the important question. Distinguish between primary, secondary, and tertiary alcohols. Primary, secondary, and tertiary alcohols can be distinguished by three methods. One is Lucas method, Victor-Meyer method, and another one is called as oxidation method. Oxidation method. Primary, secondary, and tertiary alcohols can be distinguished by three methods. One is Lucas method, another one is Victor-Meyer method, and last one is called as oxidation method. What is the Lucas method? When your Lucas reagent is nothing but zinc chloride and concentrated HCl is known as Lucas reagent. The mixture of anhydrous zinc chloride and concentrated HCl is known as Lucas reagent. The mixture of anhydrous zinc chloride and concentrated HCl is known as Lucas reagent. Lucas reagent. So the tertiary alcohol gives white turbidity immediately. Then it is called tertiary alcohol gives white turbidity immediately with the Lucas reagent. And if the turbidity is obtained immediately with the Lucas reagent, then it is a tertiary alcohol. It forms slowly, then it is called as secondary alcohol. If it does not form, then it is called as a primary alcohol. Primary alcohol. When you are treating the mixture of alcohols, what type of alcohol is present, we can distinguish by using Lucas test. If immediately we get the precipitate with the Lucas reagent, then it is a tertiary alcohol. If it is forms very slowly, then it is called as the secondary alcohol. If it does not forms any precipitate with the Lucas reagent, then it is called as the primary alcohol. Primary alcohol. And next one is a Victor-Meyer test. Victor-Meyer test is based on the different behaviors of the primary, secondary, and tertiary with nitroalkanes towards nitrous acid. Nitroalkanes towards nitrous acids. And the behavior with the nitric acid తో ఏ విధంగా ఉంది అనేటువంటి దాన్ని బేస్ చేసుకుని క్లాసిఫై చేయడం జరిగింది. Alcohols, any alcohol, either primary or secondary, first of all we have to treat it with iodine or phosphorus or HCl to form corresponding alkyl iodide. Alkyl iodide. Alcohols is treated with iodine in presence of phosphorus or hydrochloric acid to form corresponding alkyl iodide. Alcohols, first of all, we have to treat with iodine to form alkyl iodide. This alkyl iodide is reacted with silver nitrate to form corresponding nitroalkane. Nitroalkane is reacted with nitrous acid, followed by treating with alkaline KOH or NaOH. Alkaline KOH or NaOH, then we get different colors. Primary alcohol gives red color, secondary alcohol gives blue color, tertiary alcohols does not give any color. What happens here means when you are treating with alcohol with iodine, it forms alkyl iodide. Alkyl iodide is reacted with silver nitrate form alkyl nitrate. This alkyl nitrate with reacted with nitrous acid, they form nitrolic acid is formed in the primary. When you are taking in the secondary, it forms pseudonitrate. Pseudonitrate is forming. When you are taking in the tertiary alcohols, there is no reaction with nitrous acid. So there is no reaction with nitrous acid, so there is no formation of color with NaOH. So when you are adding the color, it forms the complex. It is having more. So more blood color is forming, and this is dissolved in the NaOH. It gives the blue color is forming. When you dissolve this in the NaOH solution, it gives red color. this dissolved in NaOH solution, it gives the blue color. There is no reaction, so there is no reaction with the NaOH, so it is a colorless. If the red color is obtained, then it is indicates that the primary alcohol. If it is a blue color, it is indicates that it is a secondary alcohol. If there is no color, it indicates that it is a tertiary alcohol. Oxidation. When your alcohols on oxidation, primary alcohols gives aldehydes. Primary alcohols gives aldehydes and corresponding number of carboxylic acid. Further oxidation gives carboxylic acid. Secondary alcohols gives primary alcohols gives aldehydes and corresponding carboxylic acid, corresponding number of carbons with carboxylic acid. Secondary alcohols gives ketones. Secondary alcohols gives ketones, which on further oxidation it gives carboxylic acid with less number of carbon atoms. But tertiary alcohol does not. Tertiary alcohols are tertiary alcohols oxidize to form ketones with less number, and carboxyl is also having the less number. When you're taking that, when you're taking in the primary alcohols, same number of carbons should be present in the aldehyde, and same number of carbons is present in the carboxylic acid. Primary alcohols on oxidation to get aldehydes, and further oxidation gives carboxylic acid with the equal number of with the same number of carbon atoms present in the alcohol. If you take secondary alcohols are converted into ketones with the same number of carbons present in the alcohol, and further oxidation it gives less number of it gives carboxylic acid with less number of carbons in the alcohol, number of carbons than the alcohol. ఆల్కహాల్లో ఉన్న కార్బన్స్ కన్నా తక్కువ కార్బన్స్ తో కార్బాక్సిలిక్ యాసిడ్ ఫామ్ అయితే అది సెకండరీ. కీటోన్ మాత్రం సమానంగా ఫామ్ అవుతుంది. అదే టెరిషియరీ గొంతులోకి కీటోన్స్ తక్కువ నెంబర్ కార్బన్ తో ఫామ్ అవుతుంది, కార్బాక్సిలిక్ యాసిడ్స్ తక్కువ నెంబర్ తో ఫామ్ అవుతుంది. సో దిస్ ఇస్ ద distinguish between the primary and secondary and tertiary alcohols. So this is about the hydroxy compounds. Thank you.